Welcome to Cosmic Compass. When you step outside on a clear night, you see thousands of stars overhead. They seem impossible to miss, but strangely, when space agencies release images of the moon of planets, or even spacecraft flying through the solar system, the backgrounds often look completely empty. Where did all the stars go? Why do astronauts standing on the moon with no atmosphere above them also report seeing none? Let's explore this mystery together and uncover what's really happening when our cameras and even our own eyes look out into space. When the Apollo crews stepped onto the moon, they expected a sky full of stars. Instead, they were greeted by an intense, blinding landscape. The sun's light reflected off the grey lunar surface, and that brightness overwhelmed their eyes. Our eyes adjust to light by shrinking the iris. In bright conditions, the iris closes down to protect us, reducing how much light enters. This means fainter details like stars become invisible. The moon, despite having no air, was so bright in sunlight that the astronauts' eyes behaved as if it were daytime on Earth. One astronaut mentioned he could only make out a few of the brightest stars when he stood in the shadow of the lunar module and looked straight up, visor raised. Imagine being in his place, standing on another world yet seeing a starless void. But if astronauts ever land on the far side of the moon at night and allow their eyes to adjust to near total darkness, the stars should blaze brilliantly across the sky, perhaps more vivid than anywhere on Earth. This effect is not just about human eyes, it also explains why spacecraft images rarely show stars. A camera, just like our vision, has to adjust its exposure to match the brightness of the main subject. Most of the time, space probes are photographing planets, moons, or sunlit spacecraft. The exposure settings, how long the shutter remains opened, are tuned for these bright, daytime-like objects. The shutter closes quickly, preventing the image from being washed out. But this also means faint background stars don't have time to register. Have you ever tried to take a picture of a friend during the day, only to find the sky behind them looks blank and empty? That's the same principle. The camera captures the bright subject, but loses the faint background. Now, when we deliberately want to see stars, we have to increase the exposure time. By leaving the shutter open longer, more light accumulates and suddenly the sky fills with points of light. This is exactly what happened with spacecraft like Cassini. Cassini, which explored Saturn and its moons, often took series of images with different exposures. In some photos, we see Saturn's majestic rings clearly, but no stars. In others, taken with longer exposures, the background lights up with countless distant suns. These raw image sequences show us the trade-off. We can't always capture everything in one shot. To see stars, the camera must sacrifice the sharpness of the planet. To see planets in detail, the stars fade away. What matters is what the mission is focused on. This is a subtle but important point. The stars haven't vanished. They are always there. It is the instrument and how it is used that decides what we get to see. There's another reason you often don't see stars. In the most beautiful space images, many of those pictures are not single photographs at all. They are mosaics, large images stitched together from multiple frames. Take a famous picture of Saturn. It might look like a single wide view, but in reality dozens of smaller photos were combined, each one focused on a section of the planet or its rings. The black borders between them, which might have contained stars, are usually cut away. The final composite emphasizes the planet itself and presents a clean image to the public. Why do this? It dramatically increases resolution and makes the most efficient use of data. Deep space missions don't enjoy the luxury of high-speed internet. At the farthest distances, data rates can drop to just a few kilobits per second. Sending back dozens of high-resolution frames takes planning, and mosaics allow us to build spectacular images without overwhelming the communication channels. So when you admire these breathtaking mosaics, remember they are scientific as well as artistic. The absence of stars doesn't mean emptiness, it means choices were made about what details to preserve. So why don't we see stars in most space photos? There are three main reasons. First, human vision adjusts to the brightest light in view, washing out fainter details, just as the Apollo astronauts discovered. Second, cameras set to capture bright planets use short exposures too quick for stars to appear. And third, many of the most iconic images are mosaics, where the background stars are not included in the final stitching. This means the universe has not hidden its stars. They remain countless and eternal, just beyond the limits of what our eyes or instruments are adjusted to capture. In some ways, this tells us something deeper about exploration. When we look at an image and see only a planet, we might forget the stars are still out there, but they are waiting for us to look again in a different way, with a longer exposure, or simply with patience. Perhaps there's a lesson here: the cosmos doesn't always reveal itself in full at once. Sometimes we have to change how we look or step into the shadows to notice what has been there all along. So the next time you see a photo of Saturn or the Moon with a starless background, don't think of it as empty. Instead, imagine the hidden backdrop, billions of stars, galaxies, and mysteries quietly shining beyond the reach of that single image. The stars never disappeared. They are always shining, waiting to be seen when our eyes or cameras adjust to find them. What vanishes in one moment of brightness reappears in the stillness of darkness. And maybe that's part of the wonder of astronomy. Not everything is visible at once, and sometimes the most familiar images carry secrets hidden just out of sight. The cosmos asks us to look closer to change our perspective and to realize that the universe is far richer than what we first see. So let's keep asking questions, keep exploring, and keep looking for the stars, because they've been with us all along. So the stars have never disappeared. They are always there, shining beyond the reach of a quick exposure or the limits of our daylight adjusted eyes. What seems empty in a photograph is in fact filled with countless suns, galaxies, and wonders, just waiting to be revealed with the right perspective. Perhaps that's the beauty of astronomy. The universe is deeper than what we first see. If you enjoyed this journey, join us again on Cosmic Compass as we continue exploring the hidden stories of our cosmos. Until next time, let's keep looking up, because the stars have been with us all along.